Stage 4: Probability. On the previous stage of this book, some basic counting techniques were presented to solve situations in which you have to count or quantify the results. In this stage, we will see the impact of probability on counting the numbers of results that an event can have. We will start by defining some basic concepts of probability. Next, we will calculate the probability of random experiments, in which you will make use of some counting techniques to find the number of results of an experiment. Probability, value between 0 and 1, which describes the relative possibility that an event occurs and is represented by the letter P. Experiment, an activity that is either observed or measured. Outcome is the result of an experiment. Sample space is the complete set of all possible outcomes on the experiment. Event, every possible outcome of an experiment. Certain event, formed by all the possible results of the experiment. Its probability is 1. Impossible event, an event with a probability of 0. Mutually exclusive events, if two events cannot occur simultaneously, they have no results in common. Non-mutually exclusive events, if there are any common result between two events. Conditional events, when one or more events depend on another previous event. Independent events, if the occurrence of one event has nothing to do with the occurrence of other results. In the following lessons, we will see some samples of all these types of events. Subjective probability. It is based on personal judgment, accumulation of knowledge and experience. For example, it is unlikely that my friend cheat me in the game. You must determine the probability that the defendant is guilty. In this case, we will base on the knowledge that we have on the people, if he can cheat me or not, if it's guilty or not. Frequential probability. It is based on cumulative data. For example, it is unlikely to receive today more calls than usual. We need to check how many calls do we receive per month, per week, per day. Probability that the home team wins is very high. We need to check in the past how many times does the home team have win or not. Classical probability. It is defined as the ratio of the favorable results of the event and the total result that make up the sample space. There is a little change to obtain a 3 on the die, the probability of get a red light at the custom office. In this case, we know all the possible results that we can have. That's why we can calculate the probability. On this stage, we will focus on this type of probability, classic probability. Stage 4: Probability. Lesson number 2: Probability of simple of events. The classical probability of an event P is written as P of E and is defined as the number of results that make the event E divided by the number of results that makes the sample space. Let's see this sample. We have tossing a coin and the outcome can be tail or head. What is the probability of getting a tail? First, we need to calculate all the possible outcomes. If you remember from the previous stage, we need to get all the possible results by throwing a coin that will be tails or heads. That is that we have two possible events. Now, by getting a tail, there is only one probability, or there is only one option. So the result will be 1 out of 2 if we want to write it as a fraction, 0.5 if we want to write it as a decimal, or 15%. Let's see the following sample. If two coins are thrown, what is the probability of getting two tails? First, we need to know all the possible answers that we can get by throwing 2 coins. We will use the counting techniques that we saw on the last stage. So, first, we know that in 1 coin we have 2 possible answers. In the second coin also we will have 2 possible answers. So we will have 4 as the total number of results. Now we need to get, or we need to calculate all the favorable results of getting 2 tails. We will use a tree diagram and we will see that there is only one way to get 2 tails. So the probability of getting 2 tails by throwing 2 coins will be 1 out of 4, or 0.25, or 25%. Let's solve the following sample. If 6 coins are thrown into the air, what is the probability of getting 4 tails? First, we're going to calculate all the possible results. In this case, we will use the binomial theorem. That will be 2 raised to the power of 6 will be equals to 64. Now all the favorable results. Also, we are going to use the binomial theorem, getting 4 tails. If we want to expand this binomial, we will get that on the third term we will have 4 tails. So the combination will be 6 with 2. If we write it as a quotient, we will have the probability of getting 4 tails will be the combination, the 6 with 2 over 64. That will be 15 over 64. And we have the result as a decimal. This sample we have that the box with 20 balls, from which 4 are black. If you pick randomly 2 balls, what is the probability that both are black? So first, we need to calculate all the possible results. So we need to form all the possible groups with 2 members. That will be a combination, the 20 with 2, because we are getting all the possible groups with 2 balls. Now, from the 4 black balls, we need to form all the possible groups with 2. That is a combination 4 with 2. So the probability of getting 2 black balls will be the combination 4 with 2, that is 4 black balls, all the possible groups that we can form with 2 balls, over 20, a combination of 20 with 2, there is all the groups that can be formed with 2 balls. That will be 6 over 190, and we have the result, 0.0316. Lesson number 3, Rules of Probability. The rule of addition, that is for mutually and non-mutually exclusive events. Rule of addition. This rule indicates that in calculating the probability of 2 or more events, the probability must be added. However, sometimes the probability of an event affects the probability of the other event. Mutually exclusive events, nothing in common. And it's read as P, A or B, or P union B, and we are going to add the probability of each event. Non-mutually exclusive events, P of A or B, or P union A or B, and we are going to add the probability of all the events minus the part that they have in common, and we call it that the intersection. Be careful when you're reading the exercise. That's why the OR is highlighted. Let's see the following sample. An airline provides the following information, and we have the chart of all the flights. What is the probability that the flight arrives early? We have 100 out of 1000. We have all the flights that will arrive early out of 1000. What is the probability that the flight is delayed? We check on the chart and we have 75 flights that are delayed out of 1000. In both samples we have just a single event. Now, what is the probability that the flight is delayed or arrives early? That will be the probability of A or B, and we are going to add the probability for each event. In this case, the flights, they have nothing in common. The flight could be early, could be at time, could be delayed, or could be canceled. There is nothing in common in this chart. So we just add the probability for all the events. Let's see the following sample. By tossing 6 coins into the air, what is the probability of getting at least 4 tails? First, we need to calculate all the possible results by tossing 6 coins. We are going to use the binomial theorem. That will be 2 raised to the power of 6, and we will have 64 possible outcomes. Now, there is, we can get 4 tails or 5 tails or 6 tails. We need to calculate all the favorable results. It's not necessary to expand the whole binomial. We just need where we have just 4 tails, 5 tails, and 6 tails. If you remember, the first term will be raised to the 6th power. The next one will be raised to the 5th power, and the next one will be raised to the 4th power. It's not necessary to complete the whole binomial. Now we need to calculate the coefficient. The first term, always the coefficient will be 1. The second is the exponent of the binomial, and the third term we need to calculate them. That will be the combination of 6 with 2, and we will have all the coefficients. That will be 1, then 6 and 15. This one, we get this one by the combination of 6 with 2, and we will have 22 possible results out of 64. Always we try to simplify. The fraction in this case will be 11 over 32. We can leave it like that, or we can solve it as a decimal or as a percent. On this sample we have 2 dice are rolled, 1 white and 1 black. Consider the sample space. Find the probability of getting a 2 in the white die or a 3 in the black die. First, we need to write all the sample space. In this case, we have 2 dice. That will be 36 possible results. In the white die, we have a 2, and it's in here, all with the yellow. And in the other die, we have a 3, and it's in here. So we can count all the possible results. We have 6 with the white die, and another 6. We do not count this one because it's already, or we already counted with the one die. So we will have 11 possible results out of 36. If we apply the procedure of the rule of the addition, we will have probability of A or B. That will be the addition of the first event and the second event, minus the part that they have in common, that is in here. So we will have 6 out of 36 plus 6 out of 36 minus 1 out of 36. That will be 11 out of 36.